Hello world! Welcome to my presentation about Gang of Force design pattern in C#. It is another new day and today I will be talking about the bridge pattern. In building an enterprise application, the bridge design pattern is in medium use. And by the way, all source code being used here in this presentation can be downloaded with this URL and it is also available in the description below. So, what is a bridge design pattern? A bridge design pattern decouples an abstraction from its implementation so that the two can vary independently. There are 4 participants in this pattern: the abstraction, the refined abstraction, implementer, and concrete implementer. The abstraction defines the abstraction interface. It maintains a reference to an object of the type implementer, while the refined abstraction extends the interface defined by the abstraction. Implementer, on the other hand, it defines the interface for implementation classes. This interface doesn't have to correspond exactly to the abstraction interface. In fact, the two interfaces can be quite different. Typically, the implementation interface provides only a primitive operation, and abstraction defines higher level operation based on this primitive. While the concrete implementer implements the implementer interface and defines its concrete implementation. So let's have a few images to illustrate these participants. We have this UML class diagram. Okay. As being defined in the abstraction, as you can see the diagram, it is an interface. It maintains an object and a type implementer, as you can see it here, and your abstraction contains some operation. Later you'll see in the example. I'll explain to you what are these operation that contains the abstraction interface. Then you'll see here the refined abstraction. It extends the abstraction. Okay. Then you will have a concrete implementer. It can be one or two, and so many implementers. Also, I will show you what are these concrete implementer, because on this example I will be showing you two examples so that you will have a better understanding what would be a bridge design pattern look like. So let's have a UML class diagram of the application. For the example number 1, we have the record navigation. This is the most common use of this design pattern. I've been using this pattern for quite so long now. Actually, it is very common, as you can see here in the diagram. You will have in this example, you will just have talking about the customer as an example. And let's see what are the implementers on this UML class diagram. Here your customer base is the abstraction, and the customer class itself is the refined abstraction. As you can see, it inherits from the customer base class. Then you have the implementer, which is an abstract class. Okay, you have this following methods: add, delete record, next, prior, show all records, show records. Then you have also a customer's data, wherein it is being inherited from the abstract class data object. This is your one example about a concrete implementer. Okay. Later, I will show you an advanced implementation about this one on the example too. Let's have first a quick reference of example number 2. By the way, before we proceed with the application demonstration itself, if you notice from here, we're talking about only customers. What will happen if we will talk about another model such as person or person classes or acquisition classes and stuff like that. So later on the example 2, I'll explain to you what is the another extended functionality of using this design pattern. So first, we'll have firstly example number 1. Let's go to the demo application. Okay, let me end this presentation and by the way, we have this visual example of the example number 1, record navigation. It's very common. You will have a crude functionality, and you will also have a record navigation where you can look for the previous one and the next one, and you can show all the records. Okay, let's proceed with the application itself. Let me end this one first, so that I'll be able to see the application. Okay, let me maximize the window. Hope you guys can see this class diagram that I created. I hope it is clear to your perspective. Okay, so we have this UML class diagram that I created. As you can see, we have these 4 participants. Okay, we have the abstraction, define abstraction, implementer, complete implementer. But first, I'll discuss to you about this implementer. It is an abstract class. Okay. This one. As you can see, it doesn't have any implementation first about this method. It's only an abstract class. You have this particular method. As you can see here, next record, prior record, add record, delete record, show record, and show all records. Okay, then we have this in another example. We're talking about customer, and we have this concrete implementer, concrete data. Okay, if you open this one, as you can see here, okay, we have created a list. Then on the constructor of this class, we have initialized the value of this list. We added some personalities on this list. So we have a 5 persons for customers data. And as you can see from your abstract, it has been inherited from the data object. We implement those abstract methods already here. Your next record, by the way, I forgot to explain this one, the current variable. So integer type. Will determine what is the current record that you are navigating. So when you implement the next record method, it tracks if the current record is less than or equal to the current count minus 1. Okay, if this condition is met, you will increment the current record. That means that you will have to move to the next one and display the next record. Okay, then we have this also prior record. It checks for a condition wherein if the current record is greater than 0, okay, meaning to say you are starting to navigate the record, then it will decrement. Okay. Then we have this add record method. I mean, wherein you can simply add the customer name to this customer list. You can see here. Oh, sorry. I know it's a the code in your perspective is small. I forgot to zoom it in. I hope you guys catch it up. Where are you now? Yeah, the add record now in the delete record. In the delete record, you will also have to remove the name of the customer from the list. Okay. Then on the show record only shows the customer on the current navigation, as you can see from here. It touches from the what index on the customers list. Okay. Then we have also here the show all records implementation, wherein we will look to the customers list. This is the customers list. Then we will display the customer name. Okay. So that is the complete implementer. Okay. Then on our abstraction, okay, the customer base is our abstraction class. So let's see what the abstraction is like. As you can see it here, we maintain an instance of the data object. What is this data object, by the way? From here, the data object is the abstract class or the type implementer. Okay, so we maintain an instance of this data object or implementer, as you can see this from this property. Okay. And then we have assigned a private variable to this customer base, wherein you will name what type of group these customers belong. So during the constructor, we assign it to value. Again, if you can see from here, it has its own implementation. Let's go back to the diagram first. Let me close for this one. You can see here, it has a re-implementation about the conflict implementer. However, if you can see it from here, okay, you can see here the virtual void next. The next we implement it a method by just calling the instance of the implementer type, which is, in this example, we have this data object. We just called the next record method on that implementer. Okay, and so on and so forth for the prior and other methods that we made it from this class, from this abstraction. If you can see from here, basically we're just calling it. We're just calling the implementer class. so that we will able to execute the logic behind it. So let's go back into the diagram. On our refined abstraction, by the way, we just inherited it from the customer base. If we have a closer look on its class here, okay. Then from our customer base, we override the implementation of the show all method. Okay, this is one example that we work on. What we have here in the customer, just to show you what we're going to anticipate. Okay. If you can see from here, it is calling from the base class. This is the customer base. It calls the show all method. Okay, so let's run this application and let's see how it works. Okay, we're running the playground now. Here's the application, and I'll show you the code execution first about this demonstration. Then we're talking about a bridge pattern. There you go. Okay, then yeah. Okay, then let's open the app. Okay, hope you guys see this demonstration. So let's execute the bridge pattern 1. Then we'll execute the first example. There you go. Okay, I'll have to explain to you the code execution first. Okay, here okay, in this example we instantiate the employees class. Okay, then we assign the I have the wrong example. I think I have the wrong example, sorry. And this is the code that we're trying to execute, by the way, sorry for that. And okay, here we instantiate a customer class, and we name this customer belong to Chicago, Chicago State. So on this example, we assign a concrete implementer, which is a customer data from the customer class. Okay, so that it will implement this following methods. Okay. So in this example, we will try to exercise the bridge pattern now. First, we show the record, which is the current record, which is on the index. The indexer 0 is Jim Jones. Then if we will click, we will execute the next record will be Samuel Jackson. Okay, Next, it doesn't display yet, I'm sorry. When you click next, the current navigation will be in the next record. Then when you show the show method, it will show Samuel Jackson. Then if we execute again next, it will navigate to the next record. Then if we execute show method once again, Alan Good will be displayed. And then afterwards, we add a new customer in the name of Henry Velasquez. Okay. And then if we will call the show all method, it will display all customers on the list. You can see in this example. Then Henry Velasquez is added to the new list. Okay. Okay, so let's proceed now with the example number 2. This is a very interesting thing. I'm excited to explain about this example. Okay, let me show to you first the slideshow so that I can explain to you what is example number 2 is all about. Okay. Here we have this UML diagram for our, I call it, by the way, record navigation generic. Yeah, sorry for that. It should be example number 2. Okay. I called it record navigation generic. As earlier I explained to you, example number 1, it only deals with the customer data. What will happen if we trying to deal with different types of models, such as action, location, and employee? So you'll have the multiples of classes of implementation for your complete navigate first to that for our concrete implementer. Okay, so let's see what are the participants on this record navigation generics. Okay, in this example we have this model to showcase to you what we call this one, the versatility of the implementing generics on this example. So without further ado, let's go on and explain to you about the execution about this example in the source code itself. Okay. So let me open the UML diagram. Hope you guys can see this diagram. Let me close this solution ignore. Okay. So I will start first with this basic models. As I talked to you earlier, on example number 1, it only shows a customer. What if we have this particular model Then you have an action class, a location, and an employee class. To make your application more reusable, okay, we have to apply generics. Okay, on this example, I converted our implementer and concrete implementer as generic. Okay, meaning to say you will just call for the model that you're trying to use. You don't have to implement these following methods to each model. So that's the beauty of using a generic. So on this example, same as example on the previous on our example number 1, we have this interface, and there's no implementation yet, so it will accept different type of models as a parameter. So this is how it looks like. Okay. Then it is calling to the base entity, meaning what are the models that you're going to accept on this implementer generic. You can see it here. Next thing is we have this concrete implementer generics. Okay, this concrete implementer is the implementation of those methods from the interface that we have created. I already explained to you how this one works. Okay, so same thing with the one that we discussed in the previous example. Okay. And now the beauty of using generics. Okay, we have this concrete implementer. You can see it here. The code is so minimal. You don't have to implement this whole bunch of methods from your implementer generic. I mean, from your implementer class. If we open some concrete implementers that we have call, you can see it here. See, we just inherited it from the repository class, and we call the employee. In this example, we initialize the list of employees. So that's it. And the next example, we have this repository location. You can see it here. We just call the location model. So that's the beauty of having a generic. It minimizes your code. So here we have this abstraction. Okay, we have this abstraction. Let's say, for example, our employee base. Of course, it has different first. Yeah, on our abstraction, if you can see it here, the same thing that we have mentioned earlier, but we only call the single, the instance of the implementer class, which is of generic type, because we are dealing with employees, so we will call an employee class here. So if we will want to perform an add method, you just call an employee model from its parameters. Same likewise with the delete method. Okay, if you have noticed it here from here again, we just call the method from the instance that we have created out of the implementer class. All of our methods here is calling from our implementer class. Okay, same likewise with the location. We open that one. The code is pretty much the same. It only varies from the models that you are trying to call. You can see it in here. So in this example, I showcased to you two models. Two models. So I will let you implement the third one, which is the action. At least you have a better clear guide already on how to perform a bridge design problem. So let's execute the code and let's see how the execution looks like. Okay, let me first open the code execution, then the application as well. Okay, so we'll call the bridge function example. Okay. Then we'll call number 2 example. There you go. Okay, so we call an employee class. Then we assign an implementer of the repository employee. Then we call show to show to you what is the current index to be shown. So it is Samuel Jackson, so we're able to display that one. Then we call the next method, then show it once again. The next on the line will be Good, Alan Good. Then again we call the show method, the next method, then show. Then we have Lisa Giuliani, and then we add a new employee in the name of John Doe. Okay, then after that one we show all the records of the employee. As you can see here, John Doe is already added on the list. Okay, so the next thing, we'll exercise the bridge pattern, this time on the location. So we instantiate the location, then we assign a concrete implementer for location. Then we call the show method to show to you Manila. Then we call the next, then show again the record, that would be Cebu. Then we call next, then show the record, that is Davao. Then in this example, we add a new location and call it CDO. Then we call the show all method and that's the time we show all the locations, and you can see it in the list. We have CDO as a new one on the list. Okay, I hope you guys have a better understanding about the bridge pattern, and I would like to thank you for listening on this presentation. And again, by the way, the source code of this application is in the link description below. And I want to thank you guys for listening. Goodbye.